There we go.
I can tell you that you know, I mean, I may write a blog about this, and if you would like, I'm happy to have you review it first. I would actually appreciate it if you would. But I may quote you, and I don't want to misquote you. So.
Oh,
Okay.
No problems. Except, of course, don't quote me out of context, because you know where that goes.
Everything in context.
Everything in context, exactly.
Yeah.
So, I'm going to separate out checking from testing. So, if we can spend time up front thinking about the tests that we could write and turn them into checks, then at least, as I say, we shouldn't have those defects to worry about. And that's whenever I say, whenever I use an absolute, there are always exceptions. So never get after that. So in other words, okay, so we've done one check here. Great, we came up with it. And just like you said before, oh, we should at least check if the count is not in credit. That's another scenario. If the card is not valid, that's another scenario. If the dispenser contains cash, doesn't contain enough cash. So now we can come up with 10 and 5 or 10 or 15 different checks that we are basically giving to the developer up front and saying, look, your system must at least pass these. It is necessary but not sufficient. That's the terms I always use. If you can't get the cash out, or it gives you cash even if you've disregarded business rule, then hold it, your system is not working according to those things that we can come up in advance and agree this is how the system should work. Then we do the exploratory, which is all those other things at the bottom. Oh man, how? You know, what happens if the internet connection between the cash machine and the system is down? Well, we better test that. Oh, can we write a test for that ahead of time, which then becomes a check that says if you cannot connect, then it should display a message or maybe give out cash ahead of time. So basically, there are going to be the two phases. What scenarios can we come up with ahead of time that we can say, the customer can say, this is how I want the system to operate. And then all that other stuff that you put at the bottom there, all the other possibilities, we still need to do that, and we cannot write that ahead of time. That's where the tester is mentality, I'm saying, is split into two parts. Coming up with scenarios that we can turn into checks, and then coming up with all those other possibilities, because beyond a simple system, you got to explore it. So that's my first differentiation. BDD does not replace testing. BDD replaces, or I'm going to say, if you can write a check in BDD, that doesn't mean you still don't need to check it again in an environment, but you should have a much lower probability of having to report a defect once you've done this. So that's my philosophy. BDD does not replace testing, period. There's no ands, ifs, and buts.
Why don't I write the checks later? Why am I writing them now?
The check. Oh, because if the check is a requirement, if I have to do this, if my system has to do that, why not, as a developer, there's no reason for me to turn any system over to testers unless I at least pass the stuff you've already given me.
Well, that's, if I had magic genies writing this, I mean, that makes enough sense to me. The problem is someone has to write this. That's going to take time. They have to write fixtures to attach to the system so that it can drive the system. those fixtures, if they're operating through an API, are not too difficult. I have run across one group using BDD in a API testing environment where I looked at the details of what they did. I had all these discussions with them along the lines that I just went through with you. And I concluded that what they were doing was reasonable, was a reasonable use of their time. They got good value out of it. Their reports about getting good value out of it seem plausible to me. And the reason is because they were testing through an API with minimal need for maintenance. It was a rather stable API, and they did not have a large need for variations of data in the kind of work that they were doing.
Right.
So it was dominated by functional concerns rather than state-based or logic data-based, concerns. So I came away from that concluding that this BDD stuff comprised, they were using it as part of their testing strategy. It comprised a shallow testing strategy, and shallow testing was needed in that situation and was sufficient in that situation. So I agreed with them with their test strategy after they walked me through it. It took them about an hour to show me the code,
Right.
answer my questions, do some stuff on the whiteboard, and I agreed with them in the end. Hey, it sounds like you were smart guys and you thought this through, and it looks like this is an application of BDD that makes sense. I'd be concerned if you took the same strategy and tried to apply it in any of many other situations that require that are much more data thick or state thick, you might say, state intensive.
Oh, that's interesting, because I actually suggest you creating state tables as part of a BDD, as part of your requirement gathering.
I've never seen a BDD gherkin statement. As you see, these are very given this and that, do that situation. I mean, unless you have a tool that generates 100,000 of these based on a state model, I'm not exactly sure how this fits into the old gherkin thing.
Well, okay, so let's just continue along one line.
Okay,
And get back to the rest. First of all, I consider this a nice, I'll call it gherkin outline, but I don't consider this a check yet because I don't have any data. And if I have some data, then I can start analyzing and just looking at data and saying what and what. So if I had something like this, let me just do this quickly. We have credit and card and dispenser. Okay, so let me share my screen and we'll just start with,
okay.
We'll start with that. I'll see, I can't, so.
Go ahead, I stopped my share.
Okay, yep, you're automatically stopped. So if I had that thing, first of all, if I'm gonna have a given an account, and I'm going to have something like this, whose the ID is it, or something like that, and an amount in it, okay, and we'll say it's Sam's, and it's got $100 in it, and then we have a cash dispenser has cash $60 when user Sam requests $20, then account ID amount Sam is now 80 and cash dispenser as cash 40. Okay.
So you
So
just wrote all that stuff.
I just added all that stuff.
All right.
Okay.
Here's what I would counter with.
Okay.
I would write a program that adds and subtracts, deposits and takes out random amounts of cash between some small number that's very small and some very, very large number, and then goes through a loop of I don't know, 100,000 iterations of that, which is much more interesting as a check than what you just wrote.
Well, hold on. Okay.
Yeah.
So this is one. I could do original account,
Yeah.
cash dispenser,
Yeah.
withdrawal, new account, and cash, new cash. So I could put this in 100, and man, I hate doing tables with these things, but 60. Okay. And now we withdraw 20. And now my account should have 80. Okay. And then my new cash should be 40.
Yeah,
Okay.
I would put all those checks right into the program that I would write to do this.
Well, okay, but let me ask this. How do you know for all of those checks that you've got, that's what the new account and the new cash should be? Are you just writing a formula?
It's checking it directly in the code that I'm writing. I wrote code that goes through loops with probably multiple accounts.
Right.
And also, hey, I'll throw in account transfers as well. And you give it a set of accounts, and it will just send money to the accounts, take money out of the accounts. It will do this over and over and over again. In fact, I would also throw in multiple bots running simultaneously. So I also get concurrency. And at any given moment, of course, the system knows, my test system knows exactly what the amounts in every different account should be, because it's very easy to keep track of that inside the program. And then I can check that against the actual reported amounts. Now, I did exactly that program when I was testing a system that managed expense reports. So I wrote some bots. That one bot was an approver bot that would randomly approve or reject an expense report.
Yep.
And then I wrote one bot that I created a bunch of instances of, which was business travelers that were trying to submit expense reports and then resubmit them if they were rejected. And each of the bots that I wrote 3 bots: an accountant bot, a manager bot, and an expense submitter bot. And these bots would have a certain probability of doing certain actions depending on what was in their inbox. And then I just started these bots and I let them run for a while, and then I stopped them. And then whenever I stopped them, each guy's inbox, each bot's inbox would be at a certain state. That state was a known state because the check bots knew what was supposed to happen. And now I could just compare that with the actual state of the website I was testing. So this is a superset of what you have here. It's just much more than what you have here, but it's code that I wrote.
And that's what I call the big test that you need testers for. Okay.
Well, it is a check. It's not it's still a check.
It's still a check
program. But it's not in BDD
That's
form.
nope.
It's just an algorithm, but it seems like it's more efficient to do that, which ends up covering a lot more stuff
Okay.
than something like this, which is just covering a tiny thing.
Right. And so let's just get back a moment to I'm going to call it one of the original purposes I see of BDD. Suppose you really didn't know much about this system, and we can at least come up with this simple thing. And now a developer who doesn't understand the system very well, let's see if we okay, I see the 100 that goes down by 80 and the 60 goes down by 40. Good. Okay, so at least I have an idea of how the system should work. All right. Now, you can go, okay, so what if they request $120? Oh, okay, then we shouldn't withdraw. Good, I've got another at least check to do. What if they request $80? Well, I don't have enough cash. So then I have to ask my product owner, because this is a triad. We're not doing, this is understanding the behavior of the system, not necessarily writing the actual test. Mr. Product Owner, if we have $60 in cash and they want 80, should we turn the customer away or should we give them an option to take out 60? Okay. Whichever. Now we have another given when then. Oh, Sam has 100, but he's got a credit extension. So we should give him the 120, but also then put $20 into his, give him a loan of $20. Is that what we want to do? Yeah, okay, good. And so what we're doing is not testing every possibility like you just said, but now we're trying to give the possibilities of the alternate scenarios to understand the scope of the problem. And then I could also say, hey, Mr. Product Owner, what happens if we cannot connect to the bank? Should we just have a sign that says, go away? Or should we have a default that says, it's okay. Let's just assume we can give everybody $60 as a default, and because they need some money and we don't want to turn them away. And so what we're doing is examining not necessarily all of the possibilities like you're doing, but going, what if, and trying to broaden the scope this way, not go down in all the details this way.
Yeah, okay. So my point was about, okay, if I'm going to write checks, I want to write powerful checks at least, because I'm trying to get value for my time. I don't want to spend a bunch of time doing stuff that doesn't cover a lot of ground. If I know how to cover a lot of ground, I want to do that with my tools. So that's one thing. But now you're saying, okay, but we're just trying to work out what the behavior should be. Oh, fine. But in many cases, the behavior is actually very complicated. I recall a situation with at a company that does software that guides delivery truck drivers, and there are a zillion rules that this software has to know about with regard to how many hours that they can be on duty, under which situations, and the system has to track all that, and versus their breaks, and there's sometimes forced break times they have to take, but how does that interact with problems like being in heavy traffic, a delivery taking longer than it's supposed to take? So I saw this tester work out these possibilities on a giant spreadsheet where she had broken down the laws and regulations and created this elaborate spreadsheet of all kinds of intricate little exceptional problems. I mean, that's an example of just something where it's you really have to study this spreadsheet, and the idea of turning that into given, when, then statements. There would be 150 of them or something, and would that really be easier to understand than the spreadsheet? I'm questioning whether, as these given, when, then statements proliferate and you get into more and more details, like we have issues of with this thing you're looking at right now. There are banking regulations. There are situations where someone might have multiple accounts. There are situations where their account might be in various kinds of different states. It might be a joint account. It might be a suspended account.
Oh, yep.
It might be provisionally suspended. It might be accidentally expended. You might extend somebody overdraft or not based on a 28 conditions.
Yep. Okay, you don't need to give in all the details, but
you know what I mean.
Let me just come back. Do you see the thing at the bottom where I'm actually just, in essence, creating, I could create more and more rows.
Yeah.
Sort of looks like a spreadsheet, right?
Yeah.
Well, to me, that's BDD. Okay. And now if we identify, I can start with, so the original account has 100, and, and we can just spell them out this way. We don't have to do all the repeats, but they request 120. Okay. Then we go,
right. Right. We used to call this data-driven automation.
Yeah. But in reality, it does have a little given, when, then to it, because what's on the left-hand side is given, the when is the withdrawal, and the then is a new account and new cash. Now we have no redundancy.
If you have a simple case, you can do this.
Right.
Absolutely. But you're talking about doing this before the code is written.
Why not?
Well, okay, except that if something is quite complex and we haven't decided how we're going to design it yet, aren't you specifying the design to some degree by doing this?
No, because I'm specifying the behavior the system must meet. I'm giving it specific examples of requirements.
I know, but what if I don't know what the behavior of the system is?
Well,
I want to try something and see how it is.
If you don't know what the behavior of the system is, then I can't implement something for an undefined behavior.
No, I can. I can try something and see how we feel about it.
Okay, that's different. So you have an unknown.
I'm talking about R&D. I'm talking about we haven't made a decision, but we need to try things. And so it's exploratory product development is what I'm talking about.
Okay. So
if you already know exactly what you want, and I find in many cases people don't know exactly what they want, but if you did already know exactly what you want, that's an interesting situation.
But let me go back, in fact, to your example. You had this tester create, or she created this elaborate spreadsheet of all the possibilities, 100, 150, whatever there were.
Yeah.
Right? Did she show it to the developers?
Oh, I mean, yeah. I mean, she worked with the developers on that, yes.
Okay. I have been in a place, it turns out, this was really funny. I was doing a review, and it was about a story. It turned out, it was just like a business rule thing. And so the tester was reviewing, some of the test cases they're going to write. And as I'm listening to the tester, I'm going, oh man, it sounds like this should be in a spreadsheet. So I got up to the whiteboard. I started with a spreadsheet going, okay, so give me your numbers again. I said, man, this looks like here are all our possibilities. I said to the product owner and the business analyst, I said, oh, I said, how about this? Is this right? And they said, oh, yeah, we had a spreadsheet like this. And we showed all the possibilities. And I said, you had a spreadsheet with all the possibilities and you then give it to the tester and and you could have had this communication going. Have we covered all the possibilities or not? So I mean, part of this is the collaboration that, because my thing is that if you're going to run a test, the test is a requirement the system must meet. If you know what the test is you're going to run.
Why do you say it's a requirement? I'm confused about that.
Okay, I'll get them after. Yeah, thanks. Yeah.
I think it sounds like you're talking about specification by example.
Possibly, yeah.
But the problem is that here's my fundamental problem with specification by example is that it's impossible. You can't specify something by example. There's no, it's because an example is by definition not a spec. It is a different kind of thing.
Oh no, that's a bad terminology.
Okay, well, I'm glad to hear you say that. It saves us about 20 minutes of fruitless arguing. Good, good. So let me make the most helpful statement that helps your side of this.
Okay.
So that we can be on better terms, and maybe I can save you from worrying about me. Whenever I see a highly specific, highly worked out, highly formalized, excellent specification for, say, a data file format, I immediately want to see examples of the data file. I feel like I'm not going to understand this unless I see examples. In fact, I saw one the other day for a financial data transfer format, an ACH file format, if you've ever come across those.
Yep, I'm familiar.
Yeah, and I was looking through this highly detailed description of the data file format, and it said it was defining what the amount was, and it defined the amount as $$, $$, $$, $$, $$, $$, $$, $$, cent sign, cent sign. So I thought, well, one interpretation of that is it's an integer where the bottom two integer digits are interpreted as cents, and the rest is interpreted as dollars. But I'm not clear on whether there's supposed to be, or there is allowed to be, a decimal point. I'm guessing there's no decimal point. But I wouldn't be surprised if I saw an example of this and there was a decimal point in there, and it turns out they just didn't put that into the description. Someone made a mistake. I want to see an example of this to make sure I understand it. So I love the idea of specification with examples. The idea of specification with example, very, very powerful idea.
Right.
And it's because examples are a different kind of creature than a spec. But when people say it's a requirement that this thing pass, I go, well, no, that is a check that this must pass, and the check is relating to a requirement. It's trying to express a requirement. That's what it's doing, but it itself is not a requirement. It is talking about a requirement. It gets its force from there being a requirement. The requirement is always much bigger than the check. Like, for instance, if you check that 2 + 2 = 4, you're not checking addition, you're checking one case of addition. And if that check passes, that doesn't mean addition is working.
Right.
It means one case of addition is working. The rest of the requirement may be broken for all we know.
You're right. But if you were going to check that 2 + 2 = 4, and the system, it does not give that, that is a failed test, right? Or failed check, right?
Yeah, now we know that the requirement is not fulfilled. So there's that basic
not fulfilled.
asymmetry that if it
So-
passes, that doesn't mean that the requirement is fulfilled.
That
But if it fails, it means the requirement is definitely not fulfilled.
not fulfilled. So
Yeah.
I shorten this to basically say every test is a requirement. It isn't the whole requirement, but if it is required that this check pass before you ship a system, then passing that check is a requirement of the system. It's
It's
not.
It's a
sustainable.
project. It's a project requirement.
Right.
But a problem with calling it a requirement of the system is here's what's going to happen. I've seen this happen before. People say, well, there are our requirements, and they point me at a bunch of checks. And they go, and the system fulfills all the requirements because look, see, green bar. Therefore, the system meets its requirements, therefore we can ship it. Why do we need to test it again? It already meets its requirements by definition. You know, I heard Ken say that these were requirements. So I'm really concerned about using that terminology when people will then conflate that with the more traditional sense of, I have a statement that says, for all X's, you must behave Y. That's a requirement in the traditional sense. And for all X's, you must behave Y for all future points in time. We don't know if we've fulfilled that. That's why we're testing, and we're gathering evidence about whether we fulfilled that. And checks, of course, are part of the evidence that we're gathering about that. But when we call those checks requirements, yikes, people could misunderstand quite easily.
Well, okay. When I do this, I do it in a more light. I'll call it I don't want to call it frivolous, but a lighthearted manner, saying if you cannot ship a system because of a failing test, then that test is a requirement. Even if it's not specified by requirements, it's required. So
wait, are you saying then that not only do we have requirements written down that are statements of what we want the product to do, but we have a separate thing called a requirement, which is the tester has to agree that the requirement is fulfilled, and you're also calling those requirements?
No, I didn't say that the test fulfills all the aspects of requirement. But if I have a check and we agree that, let's just take this one little give and win then. If the system does not pass this check, well, we're not going to ship the system.
But let me change this let me use exactly the same logic, but just change from check to test and say this. What if we say, I'm not shipping this system unless the tester says all the requirements are fulfilled? Isn't that exactly the same kind of logic? Does that mean that it's one of our system requirements is that the tester agrees that all the other requirements are fulfilled? Would you say that? Because it's the same thing in principle, except you're talking about a human instead of a computer program.
If I'm going to say, because I don't want to put it all on the tester, I'm going to say whatever the product manager, the product owner says, I am willing to ship this system even if that check does not fail. Okay. We leave it for the tester to be able to say, report, oh, well, these checks have failed. And by the way, this exploratory testing has discovered these defects. Mr. Product Owner, do you want the system to ship? Is it required that these tests must pass? And if a product owner says, I don't care, they're minor, let's ship it, then it's not a requirement of shipping the system.
So are you saying then that at any moment where a tester claims that there are bugs in the system, that the product can't ship, so therefore it is a system requirement that the tester does not say that there are open bugs in the system?
No, I just said
shall not say that there are open bugs in the system.
I didn't say that. I said that the tester is going to report what defects that have been found either via checks or via exploratory testing in the
Right.
system. And
Yeah.
then it is a product owner's decision
Yeah.
to decide whether they want to ship the system or not.
So
with
then are
those
you
defects.
saying that it is a system requirement that there are no stop ship bugs in a system? Is that a
In
system
fact, by
requirement?
definition, a stop ship bug would stop the shipment of the system. So yeah.
Yeah, right. So, but you would call that a system requirement, not a project requirement. I would say that's a requirement in the general sense of the word requirement, but
Okay.
it's not something that people call a requirement in terms of system requirements. That sounds like something. I mean, we used to have a sign-off checklist at Borland.
Right.
We're not going to sign off until all these things are true. And we didn't call them system requirements. We called them, this is the sign-off checklist. This is the thing, the release checklist. In order to release the product, these people have to agree that all the problems that we know about in the system are not sufficient to stop us from releasing the system. We need these 12 people to agree that that is true, or else we're not releasing the system. It's a consensus decision. We were quite proud of our consensus-based approach to shipping. There was like competition to be the last person to agree to ship, and it was considered honorable to be the last person to agree that the product could ship. The hardest person to convince, we felt that that was a healthy attitude to have, and I think it was. I was always impressed when the vice president of the business unit was there at midnight to be the last person to sign off after everyone convinced him, yeah, we really should ship this. We didn't call those system requirements, but they certainly were project requirements. We have to do this in order to, and I'm a little worried about the ambiguity, because I keep telling folks when I explain testing that when I test, I'm not ensuring that any system requirement is met. I don't have the power to do that. It's impossible for me to do that. Okay. What I'm doing is I am collecting evidence about the relationship between the product and its stated requirements. And when you say pass versus fail, I urge people not to use that terminology, because, I mean, imagine this. Imagine that, you know, your wife goes on an airplane and somebody tells you that day, oh, did you hear that airplane that your wife was on failed? You wouldn't go, oh, it failed. That's good information. You'd say, tell me what you're talking about. No one wants to know that something failed. What they want to know is what the problem is.
Right.
If I were to say a test failed so we can't ship, the responsible people involved immediately say, what's the problem and can we live with it? Right. And if we can't live with it, what are we going to do about it? But don't just tell me it failed. Tell me not only what problem, but were there 6 problems? I want to know about all 6. So I prefer to say problem or no problem. We ran these checks and we found no problems. Okay, good. We ran these checks and we found 17 problems. And I want to talk to you about the problems that we found with this set of checks. Yes, absolutely. Let's talk about those problems, because maybe they're not serious enough to cause us to stop things, which means that technically there's a failure, but not in any way that we are going to take action about.
Right.
Or maybe we take a different kind of action. We change the check, we update the check, we split the check into multiple checks that do different things. This whole fail and pass idea is so reductive that I'm worried every time I hear about it, especially when people talk about definitions of done or acceptance criteria. Do you ever hear people talk about acceptance criteria and then what you hear them say has nothing to do with acceptance? It's, in other words, if all of the acceptance criteria were met that you have just been told about in this product, the product would still not necessarily be acceptable. Have you ever heard that?
Yeah, I always emphasize that there are two sides. There is sufficient, necessary but not sufficient.
Right. Necessary
Okay.
but not sufficient. Right.
That is my complete thing. It is necessary they pass these checks. It is not
Right.
sufficient.
Well, you could say, as a first order guess, you could say it's necessary. And I love the not sufficient thing. So necessary but not sufficient is not the same thing as acceptance criteria.
Right.
It's partial acceptance criteria. But even on the other side, you might say naively, or as a first order guess, you say, I want all these things to pass. And then, but when they fail, you go, well, let's look at it more closely because maybe we can live without this stuff. That has happened. This happened to me on a medical device project where I was given requirements that the power level can't be outside of 10% of its from its target value, right? So it has to be within 10% of its target value. I did some tests. I showed the results. It's clearly outside 10% here, here, and here. Therefore, this product is not acceptable. And guess what? The division manager said, you know what? 20%. Oh, suddenly everything passes. So they targeted 10%. It didn't work out. They just changed the requirement until it passes, and which is totally reasonable, by the way. I mean, they have the power.
Absolutely, I agree with that. I mean, it's like you put a number and then you decide that number was too strict. That's perfectly
Yeah,
fine.
that's right. But so if someone says, well, these have to pass, I mean, that's not really true. What's really true is we have to be comfortable with the relationship between these statements in a specification and the product. And that may mean we change the specification, or it may mean we change the product, but we need to understand the relationship between those two things, and we have to be sanguine about that relationship. That's more of the truth of the matter. And so that's true with BDD too, right? You have these BDD statements, and you want to be comfortable with the relationship between these statements and the product that you're designing. So you might change these statements, or you might change the product. And to me, then, what I'm concerned about, and tell me how this works, because you have experience with this. What I'm concerned about is that you start writing a whole bunch of these things, and this starts gaining a real mass, like 100, 200, 300 of these BDD statements. How many? I don't know how many in a real project that you end up with in your experience, but the more you end up with, the more mass that is. That mass is a mass of things you need to maintain. It's a mass of things that gets intimidating to people. They start not wanting to change things because they go, oh, we've come so far and we've set so many things in stone. Is that not a deterrent to innovation? You set all this stuff up beforehand, and now you have to page and page and page through all these things, and it gets overwhelming.
Absolutely. So here's my difference in my approach to BDD. So we've just written one BDD thing, okay, that given when then. I go, okay, and now this is the way I present it. So you go, oh man, I've got another thing. So I'm going to copy and paste that and change some numbers. And then I'm going to copy and paste that again and change a couple of numbers. And I go, stop, time out. Whenever you hit, and this is my rule, whenever you start to mark something and go copy and paste, take your fingers off the keyboard, okay? Because whenever you do a copy and paste, you're creating redundancy and duplication. Now, sometimes you need to do that, sometimes you don't. But just like you suggested with your thing, let me create that little spreadsheet at the bottom. Now I can hit examples of all the possibilities as a row in this spreadsheet. And I don't have all these tons of given when thens. I have one just to show what the flow is. And then I have this spreadsheet at the bottom that shows all the other possibilities of what should occur. And so I'm going to do it in a spreadsheet format. And now I can fit 100 different ways of doing things in a spreadsheet, and without any redundancy. Then if I copied and pasted that same thing 100 times, you can't look at it. You can't, I mean, nobody's going to read 100 different ones to try and figure out what are the differences. So, I mean, normally I would have something like this saying, you know, I have actually another column in here that basically tried to say notes. Let's see, normal withdrawal. And then the next one would be something like, you know, this would be unable, not enough cash, not enough in account, or something like that, what have you. And so you basically, in essence, create the whole sequence of these things. And I'm always looking for those things, because the more that we can create a tabular format, the more, obviously, it's now easier to automate, just like you did. But it's also now we pulled out all the stuff, and we're listing the scenarios line by line, rather than in, oh man, it would take us like what, 10? We got about 15 lines there, and then 15 times plus 15, and nobody's going to read that stuff.
Okay, so you're not telling me that it's easy to manage all this growing mass. You're saying that you try to avoid unnecessary mass, but
Yep.
It's a lot of mass, even the necessary stuff. I mean, I noticed that what given when then boils down to is basically input-output relationships.
Yep.
Right? That's not all it is. But input-output relationships can be extremely complex with complicated algorithms. Like, how would you get into the appropriate behavior for a text differ algorithm, for instance, which is something I know about because I recently wrote a text differ program. It's rather clunky and confusing to try to document that in this format, and there's a bunch of exceptions, and it isn't clear that there's a simple input output format that's going to conveniently work for that. Sometimes you have loops, sometimes you have trees, whole decision tree that you have to traverse, and that decision tree could have many conditions. Now that might mean you have a very big table. For instance, if you let me, I can give you an exact example.
Okay, go share one.
If I separate this out and say share screen, you have to stop your share.
You should be able to just, okay, I'll stop.
It won't let me?
It's not gonna let you stop my, okay, I'll stop my.
Here's an example that's a beautiful testing example. I used this in one of my classes.
Wow.
This is apparently the logic to decide whether Slack sends you a notification. And so this is wonderful to use as a testing example, because when I worked through this to try to turn this into interesting test cases, I found there's missing information, there's ambiguity, there's a whole bunch of stuff that required me to go play with Slack to find out what the hell they're talking about. And then I saw the screen they were referring to and I go, oh, that's what they meant. So there's a bunch of tacit knowledge involved here. Now, in one sense, this is wonderful for your approach, because your approach is partly about, let's talk about this and understand it. And part of talking about it and understand it is, well, put down in some explicit form what you're talking about. And then that will help by navigating through our confusions. That will help us identify the tacit stuff that you might have inadvertently left out. But this is also an example of a complicated flow of logic.
Right.
Because, all right, so should we send a notification? Well, is the channel that you're sending the thing on muted? It's not muted. Okay, is the user in Do Not Disturb? Yes, but did you override the Do Not Disturb? Yes, I overrided it. Okay, so you overrode it. Well, but that's still, we still don't know what's going to happen there, because is this a channel message in every message or a here message? Yeah, it is. Well, are channel mentions suppressed? Yes, they are. Oh, okay, let's go down here. Well, then the answer is no. So you can see that this turns into a pretty big thing. Here's what I did.
Right.
I wrote a program that first of all, I had to work out all these ideas so that I understood them. And there were some ideas I could not work out, where I have to go to a Slack engineer and say, what are you talking about here? But I couldn't go to a Slack engineer, so I just left those as TBDs. And I said, well, based on the things I do understand, I can write code, and the code actually goes through this logic and generates every possibility. So I wrote code that enumerates every possibility. I ended up with 466,000 different distinct paths, believe it or not, through all this.
Right.
And then later on, I found a bug in my code that I had double counted something. There was a redundancy. So I was able to make that down to something like 196,000. Now I didn't finish my program. So my program partly decides whether there should or should not be a notification, and I haven't finished the oracle for the rest of it, so it doesn't completely say yes or no yet. And then that brings me to the stage of optimization, where I say, well, if I've got 166,000 of these things or whatever, then I'm going to sample them somehow. I might do a random sample of 1,000 and try it. Of course, that depends on whether I have a way to automate this or not, because I might not have a way to automate this.
Right.
But of course, if it's Slack and I'm on the team, I'm sure there is a way to work through all the APIs to just do this automatically. I'm sure the way they have their APIs, I've got to be able to hook into those APIs and actually run through all these possibilities. I feel that's probably I'll be able to do that. But that's going to be something, if I show you what my
slide it just down a little bit. I want to just see what happens in that purple box up front. Just like over just a little bit. Yeah.
Right, left, up, down,
okay,
over here.
So actually, yeah. So if all of that is a no, actually that's then a place you could break that tree down. That little purple thing is basically, so the top half could be one spreadsheet and the second half could be another thing.
It could be. What I did when I wrote the code is I broke out the factors like this: channel factors, membership status, desktop, mobile, other membership status. This was, I think, values 2 is one is for the person sending, and the other is for the person receiving. And then it goes through here and generates all this. My goal was to show testers, look, this is not so hard to do. And I ended up actually demonstrating the opposite, that, boy, this is actually pretty complex. And you're probably not going to want to do this unless you're really comfortable with code. The end result I have right here, because you're talking about spreadsheets. Okay, so here's the spreadsheet then that was constructed from this. This has all the abbreviations of all these things. Do not disturb, active and overridden. So channel muted, channel press defaults. Is it a channel message? Is there a mention or not? There's no mention. And then for some of these, it knows that there should not be a thing. So I just haven't finished the program, but this goes for, let's just, it's right on top of my thing. Let's just scroll down. I just want to see how many.
Oh, there you go. 300,000.
So this is 466,000. Yeah, but I believe that this is the older version before I noticed a weird duplication in there.
Right.
So my initial thing is I wanted to demonstrate how you could use simple code with just for loops and conditionals to walk through logic like this, and it ended up being fundamentally more complex than that. But this is kind of the point I'm trying to make. The point I'm trying to make is in real life, even something as, you think about notifications, why that's a pretty simple behavior. And then you look at this and you realize, oh my God, it's not really simple at all. It's really interestingly intricate. This is a fascinating problem. And I had to use loops, and I had to use hashes and combinations of factors to generate the spreadsheet, because I'm not going to write out the spreadsheet by hand. And how does that work in with BDD? Is it just an extension of BDD to say, okay, so you wrote this thing, and now you go over with the programmers your code and say, check me on this code. Is this did I make a mistake here? Is this logic correct? Because this is generating all of our checks, and it's not a mass of 500 given when then statements. So this is very compact, right. Very, very compact.
Right.
But it's also not English-like anymore. Now we're talking about code, and so it's not accessible the way it might have seemed before. So I guess what I'm trying to ask you to comment on is a couple of things. One is, even when you try to compress it by squeezing all the redundancy out, you still end up with something that might be a big mass of stuff. And if you've done this before you've written anything and before anyone's ever experienced anything, they might find it overwhelming in its mass and hard to cope with in a way that this a text requirements or a picture like this might taxing, because the thing about BDD is that it is rigorous, and that rigor has a cost. If you really want to get into the details and you want to take away all the fuzz and all the rose tinting and all the do what I mean stuff and get into the do what I say, boy, Simon Says can be a pretty tiresome game to play with a computer. So I guess what I want you to comment on is, in real life, when you're dealing with real life complexity, have you experienced this kind of BDD 16-ton weight falling on people's heads, or do you avoid that somehow by getting out of the BDD thing or splitting it up somehow, or how do you cope with it?
Well, okay. So let me just give you a time check. I got to go in about 10 minutes or so.
All right. Well,
but
anything
we can do this again.
It's been so helpful for me, Ken.
Right.
I'm very grateful for you
No
for
problem.
putting up with this.
So you came up with the spreadsheet. You said for these inputs, this is what the output should be. To me, although there's a lot of them,
It's not given when then, but
no,
this
no, I'm
is
just looking at the spreadsheet.
well, the spreadsheet was produced by this.
It was produced by that,
Yeah,
which is perfectly fine. So
yeah.
go back to that spreadsheet.
Okay.
There we go. So basically, given all that stuff from A through M, the output should be N.
Yeah, it's not finished yet, but yes.
Yeah, in essence. Wow.
Yes.
So now, if this is correct, I should be able to apply this to my code and say that it matches exactly what you expected.
I mean, yes, but the code hasn't been written yet.
That's fine. You have given me a check for my code. When I start to write my code, you've given me a spreadsheet with the things. That's probably, if I'm thinking automation in my mind, because I'm not going to go through and do this manually, maybe I might actually have just one method called should I display a notification or not? And that has 13 inputs into it. And maybe it does the if else's as you showed. And now I run through all of these combinations that you thankfully gave me. I test it and I go, oops, that's wrong. My code isn't working right. So you have given me a test, a check for
a pretty elaborate check, not exactly a given when then kind of thing.
Well, in a sense, you've given me you've given me 12 inputs and one output. It said, and the
And we have a transform. And essentially, we've developed a transform. Yeah.
A transform.
And now we can use this check on a unit level if you write that one unit.
Right.
We can also use this same logic on an end-to-end level when we're actually testing the actual thing. We can say randomly give me a scenario, and I'll type it into the actual thing, and then we'll see if I get the notification. And then something might be broken that, of course, is outside of the logic of Slack. It might be that mobile device notifications are disabled because some service isn't running, some service daemon it's not running, it's supposed to be running, and we'll stumble into that, of course. So all right, so I mean, yeah, I'm interested in checking. This is something I created because I think this is interesting. Also because I'm trying to promote combinatorial techniques, and I'm trying to demystify combinatorial testing. I'm trying to help testers see that it is more possible than they thought it was. I think I failed in showing that it's easy to write the code. I thought it would be easier to write this code. And unfortunately, if you don't already read Perl, then you're going to flip the bit as soon as you see this code and go, oh, forget it. I did another version of this with another situation that was was much simpler. It was just a nested for loop with some ifs, and it only took me 20 minutes to write. And so I kind of thought this would be the same thing, but it turns out the semantics here were more complicated, so I couldn't do that. And that's the other thing I'm worried about is that it's one thing to talk about depositing into a bank account. It's just basically an accumulator. It's not a basket of 900 types of objects. It's not like a shopping basket, say, that might have a bunch of different things in it. It's just this number that you're managing with some laws around it. But when you get into some of this complicated behavior with system interactions, you don't find that BDD gets too unwieldy?
if you're trying to go with the given when then and like that, as opposed to this form, yeah, it can be completely unwieldy.
So do you find that your method of using BDD or your implementation of BDD shifts and flows into different forms depending on the context? Is that what you're trying to say?
Yeah. So I'll start maybe with that given when then with that extra data, because Dan's initial thing, it doesn't have enough data so I can discover anything.
Right.
So
yeah, one of the things, that's one of my problems with it is just, where's the data? So I already see that in your approach, you just put in the table of data. So you're already data driven.
And so I put in the data, and one of the things I always do is when you look at the then part, it's got to come from one of three places. Either it's got to come from the given, the when, or a business rule. If you can't describe how the then values got there, then what's the implementer supposed to do? Well, we just put the value in, something. So that's why I always have data. So, and then I have the alternatives, like to discover more things. But then, as soon as I go, oh, well, we started to copy and paste here. Okay, I'll allow it once. But all of a sudden, and this is what I always push, is where are your business rules? Everybody has business rules. And I always want to describe those business rules in a spreadsheet format. Because then we take this spreadsheet and that spreadsheet format, and we just go, oh, I can automatically test this against some method that I'm going to write. Wow. Okay. And I've tested all the combinations. Where did I get all the 12 inputs? Well, that's a separate test how I got the 12 inputs.
Okay.
But I just want to give them these 12 inputs, yes or no.
What do you do when people don't know what they want? I mean, they know kind of what they feel they want, but they're not sure how to turn that into rules that computers follow.
Well, then we go, okay, then we need to explore a bit more, okay? Because,
so is that before BDD then? Are you saying that, well, we're not going to use BDD for this. We're going to use prototyping.
Right. We could use prototyping, any exploration. In fact, BDD, they actually have this thing now. They phased it. They call it discovery, formulation, automation. And formulation is when you come up with the given when thens, and automation is when you automate it. But the discovery process is where you're exploring without creating given when thens, exploring just like we do to come up with ideas. And if it turns out at the end of that exploration, it's like, we still don't know what we want. Well, then you don't start writing all these given when thens. You continue on saying, we don't have enough information to actually write a check. So.
Okay, so then it's not hostile to the idea of let's prototype and try some different possibilities and see how we feel about it.
Nope.
All right, because that strikes me as a really important process. I mean, I'm struggling with that right now with this note-taking system I'm trying to invent.
Right.
I can imagine several ways to do it that in my mind's eye look okay, but I know that as soon as I experience them, I might hate any one of them. Yep. For some reason that I'm not thinking of yet. Look, this has been very helpful to me. Thank you very much for your time. I do want to do more of this because I want to push into certain areas and get some stories from you, some examples of variations on this that you might have experienced, and then to show you some other examples from me and get your reactions to them. So thanks a lot, Ken.
Okay.
All right. And it's given me a lot to think about. And hey, this is my wife.
Hi.
This is Ken Pugh. I know him from Consultants Camp from way, way, way back. All right. Oh, thanks, honey. Okay, see you later, man.
Alrighty, take care. Bye.